Hey everybody, we're moving forward with our rationals unit. So the last time we were together, we talked about simplifying, multiplying, and dividing rational expressions. Rational expressions we discovered they are fractions with my numerator and my denominator both being polynomials. So all the rules that apply to fractions apply to rationals because they are the same. When it became to multiplying and dividing, I could just go straight across and then cancel out common terms between the numerator and the denominator. Adding and subtracting, there's a little bit extra work to do, okay? So the rules with adding and subtracting is the same thing as adding and subtracting fractions. In order to do that, we have to have like denominators, okay? So, and then once my denominators are the same, then we can add or subtract the numerators and just use the same denominator. So here, if I had 1/5 plus 3/5, I just go across the top. 1 plus 3 is 4/5. Here, 6/7 minus 4/7, well, I just do 6 minus 4. That gives me 2/7, okay? So here, I have two rational expressions that are being added together, okay? I notice right here, they both have an x plus 4 in my denominator. So all I have to do is take x minus 3 and add it together with x minus 2. I combine like terms. X plus x, and then we're going to have negative 3 minus 2, so this gives me 2x minus 5 over my common denominator of x plus 4, okay? We still have to identify any excluded values. So here in my denominator, my x cannot be equal to negative 4. All right, example 2. I see that I have a common denominator. They both have a common denominator of x squared minus 1. So we know that's my denominator. To figure out what goes in my numerator, I actually get to subtract. So when I subtract 3x minus 4 minus 6x plus 1, well, when I subtract polynomials, I got to remember to distribute that negative. So this is really 3x minus 4 minus 6x minus 1. 3 minus 6 gives me negative 3x. Negative 4 minus 1 gives me negative 5. Excluded values, there's nothing here I can plug in to make this equal to 0 because anything squared is always a positive number. So no matter what I plug in for this x value, it's going to give me a positive number and then plus 1. So even if I plug in 0, 0 squared is 0, but then plus 1 is 1. Okay, even negative 1. Negative 1 squared is actually a positive 1, plus 1 is 2. So this does not have any. So excluded values, there are none for this. Okay. So now we've seen what to do when my denominators are the same. So what would you do if they were different? Well, let me go back. Did I miss something? Oh, no, I didn't. Okay, sorry. Here we go. So if they were different, we would have to find a least common denominator or a least common multiple. So here, my least common multiple between 4 and 6, well, I can divide both those numbers into what? The number 12? Because I could do 4 times 3 and 6 times 2 to get 12. I could do x squared squared to get x to the 4th. Here, so hold on. I can make them both x to the 4th. There we go. y3 and y5. Least common multiple here would be the y5 because all I have to do is multiply this by y squared to get it. So that's your least common multiple when it comes to that piece. Okay. What we're more going to work with are things like example 4. So here we have to factor it out. So multiplies to give me negative 3, but adds to give me negative 2 is going to be negative 3 and plus 1. Here multiplies to give me negative 6, but adds to give me negative 1 is going to be negative 3 and positive 2. So here, to find my least common multiple, I find what they share and what they have different. They both have an x minus 3, so that's a common factor. And then I also have an x plus 1, and we also have an x plus 2. So you're listing all the different factors they have together. That becomes its least common multiple. Okay. What if I were to ask you to add together Yes, we're skipping this, and that's okay. What if I asked you to add together 2 over 6 plus 3 over 10? Okay, well, from here, okay, I can't just add straight across because 6 and 10 are not the same number, okay? So I need to change them to where they both are the same number. Well, what could I do that? If I multiply all of this by, what, 5? And I multiply all of this by 3, then they both have a denominator of 30, right? So this is going to be 10 over 30. This becomes 9 over 30. So I've multiplied each fraction by a multiplier to get their denominators to match. Once they match, then I can add across the top and keep my denominator the same. So this would be 19 over 30. Okay, same thing has to happen when it comes to adding and subtracting rationals. Okay, so if I have x and x squared minus 2, we always factor first. That's still our first step. Okay, we always want to factor each denominator. That's going to help me find my least common denominator. Okay, so if I have x and then I have x times x minus 1, well, what are all the separate factors? Well, they both have an x, so that's one of them. And then they now both need to have an x minus 1. Okay, so I multiply with what's missing. My first fraction has the factor of x, but it doesn't have the factor of x minus 1. So I have to multiply this whole piece by x minus 1. And now, because I brought that in, now they're both the same thing. Okay, and since they're the same thing, now I can take 1 times x minus 1 and add 2 to it. All right, so 1x minus 1 plus 2 is what this should say. X minus 1 plus 2 leaves me with x plus 1 over x times x minus 1. You can bring it back together like this if you want to. You don't have to. That step is unnecessary because honestly, when you leave it like this in factored form, your excluded values are easier to see. So here, x cannot be 0 and x cannot be 1. So I like leaving it in factored form. All right, so now let's try to add and subtract some that do not have common denominators. All right, my first one, we have x minus 3 over x squared plus 3x minus 4. The other one is 2x over x plus 4. So I always have to factor first. Okay, that is the biggest thing you have to remember, is always factor first. Okay, so the only piece I can factor is down here. X squared plus 3x minus 4. So I think what multiplies to give me negative 4, but adds to give me a positive 3. That is going to be positive 4 and negative 1. Okay, so now I look at my denominators. Look, they both have an x minus 4, right? But I can't add them because this doesn't have an x minus 1. So if I put it in its place, I got to remember to do it to both pieces. So now my numerator is x minus 3 plus 2x times x minus 1. And all of that is over a common factor of x plus 4 and x minus 1. Okay, now we just simplify my numerator. Okay, so I'm going to multiply that through. This becomes x minus 3 plus 2x squared minus 2x. Sorry for my handwriting. I'm going to move it down here. We know what my denominator is. It's this. So we're going to have 2x squared. X minus 2x is going to be negative x, and then negative 3 on the end over x plus 4 and x minus 1. If you want to factor the numerator here to make sure you don't have any more common factors, it's probably a smart idea. You would have to do slip and slide, and I'll just go ahead and show you. If you do slip and slide, my numerator factors to 2x minus 3 and x plus 1. My denominator is x plus 4 and x minus 1. So as you see, nothing else can factor, so this is it. And then our excluded values, looking at my denominator, x could not equal negative 4 or positive 1. All right. So sometimes you can factor at the end and cancel some pieces out. It's not always going to happen. Like, so here we factored to look, but nothing actually canceled. So sometimes it works, sometimes it doesn't. Just always factor and see. Example 6. We have x over x plus 2 plus negative 8 over x squared minus 4. All right, well, my piece I'm going to factor is my second denominator. This is the difference of squares. So I know this is going to be x plus 2 and x minus 2 is how that factors. So that's gone now. Now look at both pieces. They both have an x plus 2, but this side does not have that x minus 2. So I got to bring it into the denominator, which means I have to also bring it to my numerator. There we go. I'm going to multiply this through. X times x gives me x squared. Negative 2 times x gives me negative 2x. Over x minus 2, x plus 2. And we're going to add to this negative 8 over x minus 2 and x plus 2. So now that my denominators are the same, I can add across the top. I don't have any common terms, do I? So that's going to become x squared minus 2x minus 8 over x minus 2 and x plus 2. And just like last time, sorry guys, my tablet shut down. Okay, so we're at this point where we have, there we go. Is it not going to erase? No. So we're at this point in my equation where we have added together, sorry, I can't talk and do things at the same time. There we go. Okay, so I've added my numerator together. There's no like term, so it becomes x squared minus 2x minus 8. And my denominator is going to be x minus 2 and x plus 2. Okay, just like last time, I'm going to factor my numerator, see if something can happen. So let's see what multiplies to give me negative 8, but adds to give me a negative 2. That is going to be negative 4 and positive 2 over x minus 2 and x plus 2. And in this case, we actually did have something cancel out. My x plus 2's cancel. So we actually simplify to x minus 4 over x minus 2. No more common factors, that's it. When I list my excluded values, again, account for everything that was once a denominator, so go before you started canceling things out. So I cannot have x equals positive 2 right here or negative 2, because that would make my denominators equal 0 at some point. All right, it's time for you to try. So we have x plus 4 over x squared minus 2x plus 1 plus 2 over x minus 5. So I want you to pause and I want you to try one. Check your work with mine, see if we got the same thing. My denominators both had an x minus 5, but the second fraction was missing the x plus 3, so I multiplied that through. That simplified my numerator to be 2x plus 6. So when I add that to x plus 4, x and 2x is 3x, 4 and 6 is 10. I cannot factor that anymore. It is done. So that is my simplified rational expression. And then my excluded values, we could never have an x equals 5 or negative 3, because that would make my denominator equal 0 somewhere. Good job. Okay, let's move on to subtracting. Okay, well, if you remember back in the beginning, we did some subtracting fractions, and it was the exact same as adding, except I just had to move my negative over. So before you do anything else, before you factor, before you move things, move this negative up, and then make that back into a plus sign. Okay, so distribute the negative through, and now it's plus, and now it's just like the one we just did. Okay. Looking at these denominators, I have 2x plus 5 and 5x minus 2. I cannot factor either one of these. So for them to be common denominators, they both need the other piece. So I need this piece to have 5x minus 2. And I'm going to need this piece to have a 2x plus 5. Now my denominators are both 5x minus 2 and 2x plus 5. Their denominators match. All right, let's simplify. So over here, we will have to FOIL. So we're going to get 15x squared minus 10x minus 6x, and then positive 4. My purple is going to simplify to negative 4x, and then minus 10. I'm going to go ahead and simplify that numerator before I put it back over my denominator. My denominator is not going to change. So from here, let's see, it stays 15x squared. Negative 6 minus 4 is negative 10. And then 4 minus 10 gives me negative 6. And this should definitely, I mess up? Oh, I did. That's negative 16, negative 4. That should definitely be a negative 20. There we go. I'm looking at this. I can't factor it. I can't divide the whole thing by a number. 5 won't work. 4 won't work. 2 won't work. So that's going to be my new numerator. And my common denominator is the 5x minus 2 and the 2x plus 5. Our excluded values. So what's going to make each of these equal to 0? Here, if I added 2 and divided by 5, that would give me a positive 2/5. Here, subtract 5 divided by 2, that gives me negative 5/2. Those are the two pieces I cannot let x be equal to. All right, let's go to number 8. All right, we have 2x squared minus 30 over x squared plus 9 minus x minus 5. So again, the first thing I'm going to do is make this into an addition problem. Doing that, this becomes negative x and negative 5, and now the whole thing is a plus. Okay, so we distributed our negative to both pieces. And this is now negative x, negative 5. They both change their sign. All right, looking at my denominators, it looks like this one is a difference of squares. So this gives me x plus 3 and x minus 3. So they both share the x plus 3, but this piece is missing the x minus 3, so we're going to multiply it to top and bottom. My numerator, so the first numerator is still the same. It is still 2x squared minus 30. My other side, we're going to distribute and simplify. So negative x times x is going to be negative x squared. Negative x times negative 3 is become positive 3x. Negative 5 times x is negative 5x. And negative 5 times negative 3 is positive 15. I know my numerator. I'm not worried about it right now. Let's simplify this hot mess that we have. Looks like 2 minus 1 is going to give me an x squared. Then I have 3x minus 5x, which gives me negative 2x. And then negative 30 plus 15 gives me negative 15. Whoop. Now let's bring my denominator in. All right, just like last time, let's try to factor our numerator and see if we can simplify anything. Does anything multiply to give me negative 15 and add to give me a negative 2? I believe that is going to be negative 5 and positive 3. And look at that. We are going to get to cancel out a common term, which is the x plus 3. So we are left with x minus 5 over x minus 3. And my excluded values for this problem comes from my denominator, so I could not have negative 3 or positive 3. I'm going to say x cannot. X cannot be negative 3 or positive 3. Okay. I want you to try this one. Go ahead and pause, try it, and then come back. Okay. So this one was probably one of the hardest ones we've done. So when I factored my first denominator, it was x times x minus 2. My other one was just an x minus 5. So my first fraction was missing the x minus 5. My second was missing the x and the x minus 2. So after I distributed the negative to my second numerator, I went ahead and multiplied both pieces by x and x minus 2. The left side, when I multiply, it becomes x squared minus 5x. The second numerator multiplied all of that out. It gives me a negative x cubed plus 2x squared plus 2x squared minus 4x. I combine like terms to get negative x squared plus 5x squared minus 9x. I did try to factor it. So what I did, I took out a negative 1. I took out an x from all those pieces. And I could cancel an x out of the top and bottom. I cannot factor anything. I can't multiply anything to give me 9 and add to give me a 5, so that piece is not factorable. So I just multiplied the negative 1 back through and left it as negative x squared plus 5x plus 9 all over x minus 5 and x minus 2. That's probably one of the most difficult ones you will ever work with. I will say it's harder than anything I'm going to put on a test or a quiz in the future. But I did just test a lot of your math skills on this one. So if you struggled a little bit, don't worry too much, you'll be okay. You have a worksheet today, another 8 problems. 4 of them are adding, 4 of them are subtracting, which, as you have figured out, subtracting is the same thing as adding. You just distribute your negative sign through first. So work on that and let me know if you have any questions.